Okay, so this video is about acceleration, what it is, and how you can calculate it using some other stuff that you might already know or be given by a situation. All right. So what is acceleration? Basically, acceleration is defined as a change in velocity over a period of time. So essentially, if you've got an object that's moving, it will have a velocity, its position will be changing, so the speed at which its position changes is its velocity, if you're also including the direction that it's traveling. So how fast its position changes, that's velocity. And then how fast its velocity is changing, assuming that the velocity is not constant. If its velocity is changing, then it will have an acceleration, and we can calculate that. Right. So here's a couple examples of things that accelerate in a rather dramatic fashion. This one here is NASA's Saturn V rocket, which was used to send quite a few men to the moon. Up here is the part that the people occupied, just that very tippy-top portion. Anyway, that's pretty cool. It got going insanely fast, very quickly, lots of acceleration. All right, and then here we have a standard race car. Lots of acceleration there too, not quite as much as the rocket, but a lot more than a normal car. All right, so and then we have our little definition here. Acceleration is basically how fast the velocity of an object changes. Now we're going to use this little white part here to go ahead and write down an equation for this. Okay, so basically we're going to use little a. Acceleration is equal to the change in velocity over time. Now, if you've had math, you've probably seen this symbol before in math, I hope. Maybe not, but this is what we mean. This triangle means change. So a change in velocity divided by how long it took, we just represent that with a t for time. So that is your acceleration equation right there. Acceleration is equal to a change in velocity divided by how long it took, divided by time. All right, now there are, as we just showed, that's the equation, but there are actually two ways to calculate acceleration. The first way is exactly what we just showed on the previous slide, change in velocity over time. Now, what do we mean by that? Well, we can get more specific. We can say Vf minus Vi divided by time taken. So what is Vf? That's final velocity. Vi, that's initial velocity. So this is essentially the equation, and then if I want to write it in here, divided by time, right? It's hard to do that with text. So that is that. Now let's go up here and read it as words. We know that if we know the initial velocity, the final velocity, and the time taken to reach the final velocity, that's when we use this equation. All right. So how do we do it? Well, this is an example of real numbers for a real Saturn V rocket. So I got these from Wikipedia and How Stuff Works, those two websites. So how do we do this? Well, we apply the formula. So A is going to equal, and V final is 2,750. V initial is 0, so I'm going to just leave it off. Actually, you know what I'll do? I'll go ahead and draw it in just for completeness. Minus 0, and then we divide by how long it took, 165 seconds. So this is going to give us our answer in meters per second per second. All right, I'll write that in a minute. All right, now if you work this out in your calculator, you're going to discover that this is going to be 16.7 rounded off, and then the units there, as I was just saying, is going to be meters per second per second. That's one way you can write it. It's basically the change in velocity, the change per second in velocity. So this rocket is increasing by 16.7 meters per second every second. All right, there's another way to write that, which is much more common, and that is to write it as this: meters over second squared. So meters per second squared. This is your unit for velocity. For velocity. This is your units for acceleration. All right, units for acceleration. All right, so meters per second squared, that's your units. All right, let's look at the other way you can calculate acceleration. All right, this is one way. The other way is as follows. Okay, so if you have a velocity time graph instead of numbers that you're working with, well, it's actually really simple in this case. The acceleration on a velocity time graph is equal to the slope of the line. Or if the line is really squiggly, you might do an average between 2 points, an average slope between 2 points on the graph. But in any case, regardless, the velocity time graph gives you a line or curve, and the acceleration is equal to the slope of that line or the slope of that curve. In this case, we have a very simple line. So if we look at this, we've got here the furthest point looks like 8 and 16. So slope is equal to rise over run. So what you have there is a rise of 8 meters per second. Sorry, that's not true. You have a rise of 16 meters per second, and it took 8 seconds. All right, so here this rise is 16, the run is 8. So what we have here is slope is rise over run. So what we have is a rise of 16 and a run of 8. So we're going to say rise over run is equal to 16 meters per second divided by 8 seconds. So in this case, the acceleration equals 2 meters per second squared. That's pretty fast still, of an acceleration. But in any case, there you go. That is how you would calculate the acceleration given a velocity time graph. So now you know actually 2 ways to calculate acceleration. You know how to work with speed time graph, velocity time graph, and distance time graph. We are in good shape so far for working with motion. So that's it for this video.